Okay, in this question, we have the following experiment is performed. In experiment 1, and the nickel metal is introduced in a solution. We have the nickel in a solution of a cupric sulfate. Cupric sulfate, the important ion in the cupric sulfate is CO2 plus. The reaction produces a brown deposit of copper. In experiment 2, an iron powder Fe is oxidized. Oxidized means loses electron to change into Fe2 plus ion. In a solution of nickel sulfate, the important ion in nickel sulfate is Ni2 plus. Experiment 3, nothing is observed when an iron is added to solution of magnesium nitrate, which is Mg2 plus. Refer to experiment 1 and 2 specifies oxidizing and reducing agent. In experiment 1, oxidizing mean gaining electron, and reducing agent mean losing electron. Since CO2 plus is a change into Cu, this means CO2 plus cation is gaining 2 electron, so it is a reducing oxidizing agent. Then since CO2 plus is changed into Cu, this means it gains 2 electrons. Then CO2 plus is an oxidizing agent. Since Ag is CO2 plus is an oxidizing agent, then an I metal that is placed in this solution is a reducing agent. So Ni is a reducing agent. This is in experiment 1. In experiment 2, since Fe is oxidized into Fe2 plus, so in experiment 2, Fe oxidized to Fe2 plus, then Fe is a reducing agent. This is the definition of reducing agent. It's a chemical substance that loses electron or undergoes oxidation, or it is oxidized. Then Fe is a reducing agent. Then the solution which containing Ni2 plus, and Ni2 plus is an oxidizing agent. This is for experiment 1 and 2. The second part, 3.12, write their corresponding half reaction. For each of the experiment, we will write the corresponding half reaction. For experiment 1, CO2 plus 2 electron give Cu, since it gained 2 electron. Ni is a reducing agent, loses electron. Then Ni will give or change into losing electron Ni2 plus. The ion of Ni is Ni2 plus 2 electrons. This is reduction half reaction. This is an oxidation half reaction. In second experiment, Fe is oxidized, changed into Fe2 plus. So the first half reaction, Fe changed into Fe2 plus 2 electron. Oxidation half reaction. So Ni2 plus is an oxidizing agent, mean Ni2 plus gain 2 electrons. Since have a positive charge 2 plus, so it will change into Ni. So it is a reduction half reaction. Deduce the overall equation in experiment 2. Then we must add the above two half reaction. We must say number of electrons in oxidation half reaction must be equal the number of electron in reduction half reaction. Since we have same number of electron in each one, same number of, we directly add the two half reaction by eliminating the electron. Then overall equation will be Fe plus Ni 2 plus give Fe2 plus Ni. This is the overall equation for the redox reaction in experiment 2. Compare the activity. We must deduce, we compare the which one is more active than the other, the activity of metal in each experiment. In experiment 1, we have nickel metal in a copper sulfate solution or cupric sulfate solution. Since in experiment 1 we have a chemical reaction, then the nickel metal is more active. Then when there is a reaction between a metal and a solution, the metal is more active or has more tendency to lose electrons. Then in experiment 1, Ni metal is more active, or we can say has more tendency, in another way is more tendency to lose electron than Cu. Then we compare the element as a metal. We compare Ni as a metal and with Cu as a metal. We don't write Cu2 plus. This is not a correct one. In experiment 2, since there is a reaction and Fe undergoes oxidation, loses electrons, then Fe is more active than nickel metal and I. We can't write wrong to write Fe2 plus, or we write Ni2 plus. We compare the activity of metal and not the activity of ions. In experiment 3, since then there is no reaction, this means that the metal used is a less reactive one or has a low tendency to lose electron. So in experiment 3 we have an iron is placed in a solution of magnesium. Since there is no reaction between iron and a solution of magnesium or magnesium ion, this means iron is less active than magnesium. Okay, then Fe is less active than magnesium metal, and it is wrong to write Fe2 plus or Mg2 plus. We compare, this is a wrong way to write the ions. We compare the activity of metal. According to the previous part, arrange the different metals on axis of increasing order of tendency to lose electron. We write a horizontal axis. This represents the increasing order of tendency to lose electron in this direction. And we have 4 elements for metals, 1, 2, 3, and 4. According to experiment, Ni is more active than Cu and Fe is more active than Ni. This means Cu is the least active. More active than Cu is Ni according to experiment 1. According to experiment 2, Fe is more active than an ion, so Fe in higher position, and Fe is less active. This means Fe is before magnesium, and magnesium mean is more active than ions. This is for this question.